Hi guys, now let us look at an example to understand more on this topic, radius of investigation. Let's look at the question. A flow test is to be done on an exploratory well for sufficiently long to ensure that the well will drain in a cylinder way of more than 1000 feet radius. Preliminary well and free data analysis suggest the following values are obtained from the reservoir. Okay, the first question in A is that what length of flow test appears advisable? Next, time required to achieve stabilized flow of stated length, and C, what is the suggested flow rate? Okay, to answer our first question, what length of flow test appears advisable? In the question, it is given that the flow test is to be conducted to drain in a cylinder method of more than 1000 feet. So the minimum drainage radius should be more than 1000 feet. To answer the first question in A, any values above 1000 feet radius is acceptable length of flow test. Next, question in B, time required to achieve stabilized flow of stated length. The question in B refers back to the question in A. It is referred to the length that we have chosen to conduct the flow test. So we have to take the values of the length from A to be plugged in a formula to be given later to answer the question in B. So now let us question to answer in B. So from the question, it is given that the radius is 1000 feet with the porosity of 0.2, permeability of 100 millidarcy, viscosity of 0.5 centipoise, and the total compressibility of 2 times 10 to the power of negative 5 over psi. So the solution to answer B is that the formula is given as time equals to 948 times porosity times viscosity times total compressibility times radius of investigation to the power of 2 divided by permeability. So for in this instance, I have chosen radius of investigation F 2000 feet, which will give me the answer of time 75.8 hours. So the reason behind for me to choose 2000 feet is that I have selected a radius which is twice of the given minimum radius for safety reasons. Next, to answer the third question, what is the suitable flow rate? So to answer the question, we first need to understand the principle behind a radius of investigation. Time is actually independent of the flow rate. The time here refers to the time where the flow or pressure transient occurs reaches the borders of the boundary of the reservoir. So any flow rate is actually suitable to run the well test, or for instance the flow test. But we should be cautious enough that the flow rate should be large enough so that we can observe the pressure change that occurs throughout the time. So with that, I'll end my presentation. Thank you for listening and hope that you have enjoyed my slide. Thank you.